initially I was going to focus on alcohol, smoking and substance use, but I've decided to broaden out the talk to more of a general talk on dementia prevention, dementia risk reduction and what we know about the field and some of the challenges, because I figured that probably I'm not speaking to an audience that knows a lot about dementia per se. So I will be covering off alcohol and smoking within that and some prescription medication, but I'm going to give you a broader picture of the field, and also we really need to understand the big picture in this area because it's so complicated and has so multi-causal. So the prevalence of dementia is increases with age, and this is a global phenomenon. So we used to say it doubled every decade after the 60s, and you can see this occurs in all continents. There is some variation with some, but we're not sure if that's reliable variation. So really by about the mid-80s, about a third of the population will be diagnosed with dementia, and that can go up to about half in the 90s. So it's highly prevalent. And then if you look at cognitive impairment that's not dementia, 20% of adults aged 17 and older have that level of cognitive impairment that's clinically diagnosable. So we're looking at a major problem, a major burden of disease that affects a large number of the population. Globally, the prevalence is 5 to 7% over the age of 65. In 2010, there were 35.6 million people living with dementia, and that's expected to increase to 65.7 million by 2050. The highest number of people with dementia are living in low and middle income countries, and the greatest increase in the prevalence of dementia will be in low and middle income countries. It's more prevalent in women, particularly at older ages. Initially, this was attributed to women living longer than men, but there's now increasing evidence that Alzheimer's disease is more prevalent in women, that women are more susceptible to Alzheimer's pathology and their apolipoprotein E genotype, which places them at risk if they have it. And the reason we have an increase in dementia is not because it's easier, because the population is becoming more vulnerable to dementia, or because of anything that we're particularly doing to ourselves now that we didn't do in the past. It's simply due to population ageing. And if anything, in high-income countries, we're starting to see some of the incidence of dementia decline due to better management of vascular risk factors and high levels of education in the population. But this isn't going to really make much of a dent on prevalence. Prevalence will just keep increasing due to population ageing. So just to give you a bit of a framework around cognition, particularly for those who don't have a cognitive or psychology background, the way we think about this in the field, we look at trajectories of cognitive ageing and different phenotypes that people might end up with in old age. So what we'd all like to have is normal ageing. Let's see if this works or not. No. Oh, yes, it does. So this is where we'd all like to be. So we think of the life course, and we see normal cognitive decline in ageing. We do have some people that will show some preclinical brain changes that we could measure in the laboratory, but they won't impact on their function in everyday life. And then we have people that actually meet criteria for mild neurocognitive disorder in DSM-5, which is what we used to call MCI, and that could have multiple causes. So it could be Alzheimer's pathology, Alzheimer's disease, it could be due to vascular changes, it could be due to HIV, it could be due to Parkinson's, it could be due to MS, it could be, but the majority of this is actually from Alzheimer's disease and vascular cognitive impairment. And then that progresses to major neurocognitive disorder, which is what we call dementia in everyday language, but in DSM-5 is now called major neurocognitive disorder. So what we'd like to do is keep everybody up here, and the way we see it in prevention is that this trajectory has actually got some modifiability. So we're not just fixed on a trajectory. There are things that we can do to either increase or reduce our risk of cognitive decline in dementia. And that's the kind of premise of the whole field that we're working in. So underpinning this idea is the concept of neuroplasticity, that the brain, it isn't fixed. Like I remember in first year psychology, I was taught that we had a fixed number of brain cells, University of Sydney, a long, long while ago. We now know that there is neuroplasticity and that there's changes in the structure and the function of the brain, that the morphology of neurons and tissue density are actually regionally specific, and that there's particular areas of the brain that atrophy faster in normal ageing, and they are in the hippocampus and the prefrontal cortex. The hippocampus being particularly vulnerable in Alzheimer's disease, And there's also a change in the expression of neurotrophic factors such as BDNF, and that can also be modulated through interventions such as physical activity. We've also got a lot of evidence now from animal studies showing that animals raised in enriched environments have more dendritic spines in their cortex, etc. So we have an understanding of why the brain is plastic now. And then if you look at the animal studies, you'd see some basic interventions which have been shown quite clearly in laboratory studies to improve cognition in animals, and they are cognitive exercise, so giving rats complicated maze tasks leads to better brain function. Caloric restriction, which is very well established in the animal literature, and there's now some human studies that is just starting to be published on caloric restriction. Physical activity, which is shown in animals and in humans to stimulate neurogenesis, and particularly in the hippocampus, which is what we'd really like to see in terms of memory ageing, and stress reduction. So that's all been shown in the animal literature. So what about human studies? The way we look at human studies, we mostly use observational research in this field because it takes a long period of time to look at brain ageing. It takes decades. We need cohorts that are well characterised, that are followed for a long period of time. Ideally, they would be population-based, but they may be registry-based or volunteers. We depend on statistics to adjust for confounding and evaluate bias. And we have to understand the disease process and the context and the history effects and cohort effects, etc., etc. So it's quite complicated. We do have clinical trials in this field, but the problem is even the big clinical trials tend to be 5 years, and yet we're looking at brain changes occurring, say, over 5 or 6 decades and trying to make inferences from a trial, say, something like omega-3 fatty acids given as a neuroprotective intervention for 2 years. How does that compare to eating fish, having a diet high in fish over 60 years? So there's a lot of problems with the inferences, and a lot of the trials may be conducted at the wrong age. So we need to, if we're going to conduct a prevention trial, what age would we intervene, etc. So we need to draw from all of these different sources, and then we also have neuropathology studies, which are really important in the area of neuroimaging. So I take a population health approach to dementia risk reduction, and why is that? It's because you can see that there's very high prevalence of the disorder. The risk factors come from multiple domains that affect the health status of populations. The modifiable risk factors account for a substantial proportion of cases of dementia, and so the population strategies have potential for a very large impact in changing that trajectory in the population. So it's a very logical argument for using a population health approach to tackling cognitive decline in dementia. So that's the sort of broader framework. And then there's other arguments for having very specific clinical foci for specific groups who have known diseases, pathologies, etc. For example, head injury. There's groups that may have particular conditions. So we looked at the population attributable risk of the 7 most common risk factors for dementia in Australia, and these are the 2 that are the biggest in Australia are insufficient physical activity and midlife obesity. The others on the list are smoking, low educational attainment, diabetes, midlife hypertension and depression. And if you combine all of these, they account for a substantial population attributable risk of about 48%. Now this is higher than some of the international statistics, and that's because we have a higher level of physical inactivity, and we also have a high level of obesity than the global statistics. So it's a problem. Again, this justifies a population health approach because we've got some big risk factors here that they're accounting for a lot of the cause. Another way that we look at this from the population level is the amount of life that you live without cognitive disability. So this is just another way of thinking about the data. We can look at, we take a data set and we look at how long people have lived. We want to divide their life into healthy life and unhealthy life, and in this case we're looking at healthy cognitive function, life lived with healthy cognitive function and with impairment. And in this paper, which analysed a data set which was 9 pooled longitudinal studies of ageing in Australia, we found that the more risk factors you have for dementia, the less life you live with, without cognitive impairment, and that there was a gender difference, and education is a very big moderator of this. So what do we know about the evidence? I'm just going to focus and really, in a sense, give you a real Cook's tour of what we know about the evidence on risk factors for dementia. The field has just come to a point now. We've just published the WHO guidelines on risk reduction, and we've also my group's just published GP guidelines for Australia, and we're just at a point now where there's enough evidence to start to make some firmer statements. On the other hand, we also analysed the evidence gaps, so there's still big gaps in what we know. So I'm just going to give you a very quick tour, but I can also point anyone to references if you're interested in the actual sources of the evidence. So to structure the way we think about this, I use this model. We think about 5 risk domains: the dementia biomarkers, the demographics, lifestyle, medical and environmental domains. And the idea is that all of the risk factors that I'll be talking about act on some common mechanisms. So things like inflammation, the development of white matter changes in the brain, either leading to stroke, microbleeds or Alzheimer's pathology, etc. And then over the life course you end up with your particular phenotype, which is ideally healthy cognitive ageing, or it may be typical cognitive ageing or accelerated. So for the demographic factors, the older you are, the greater your risk of dementia. We saw that in the very first slide. And females greater risk. Low education is probably arguably the most important risk factor for cognitive decline in dementia globally. If we had to do one thing globally, it would be to increase education in low and middle income countries. Within country, there is geographic variation in rates, and that's been linked to things like socioeconomic status and education and lifestyle risk factors, and there's also differences between countries. So the ones that get most, I guess, air coverage and into the papers are the lifestyle factors, because these are things that we can all relate to and do something about, and they're also common to a number of other chronic diseases. So I'll talk more on some of these specifically. So physical activity throughout adulthood reduces risk, and this one is the lifestyle factor for which I would say there's the biggest consensus, the most evidence, and the WHO guideline was the most confident. So WHO has conditional recommendations versus sort of stronger recommendations. So it had a strong recommendation around physical activity. Being sedentary increases the risk. This is just general dementia. It's mostly, when I say it reduces risk, it's mostly based on studies of Alzheimer's disease, because most of the epidemiology is either looked at Alzheimer's disease or any dementia. There's very little epidemiological or limited epidemiological data on the rarer dementias and even vascular dementia. So when we conducted a big systematic review that we published this year, where we looked at all of the meta-analyses on risk factors for dementia ever published, we found there were only data on 8 risk factors for dementia for vascular dementia, whereas there's something, I think it was 33 for Alzheimer's disease. So this is primarily Alzheimer's disease. Smoking increases the risk. I'll talk more about that. A cognitively active lifestyle is thought to reduce risk, but there's an issue of reverse causation with that one. Most of the data is from older adults, and as you develop cognitive decline, you start to withdraw from cognitively engaging activities. So it's still, we'd still like to see some harder data underpinning that finding. Brain training is unknown. It's very, very controversial. There's a very big court case in the US with Luminosity being sued for making claims that it prevented dementia, or reduced risk. I'd have to get my wording right, but some of the cognitive training trials have shown benefit, and the WHO guidelines actually recommend cognitive training, but it was really based on the active trial that was done on a computer in a supervised study, another big trial. Diet, there's a lot of research emerging on diet, so I'll go into this in more detail, but the oily fish consumption has been associated with reduced risk. The MIND diet, the Mediterranean diet and the DASH diets have all been shown to reduce risk in different studies, and saturated fat may increase risk, and I've got another slide so I'll go into it in more detail. And we've just got emerging evidence now that sleep problems in general increase risk, but it's unclear which specific types of sleep problems. It's just general. If they've been the meta-analyses, it's just pulling together studies that have looked at different types of sleep problems. The medical risk factors, diabetes, so that there's the most evidence of diabetes out of any of the medical risk factors. So that's there's very strong evidence for diabetes, both type 1 and type 2, increasing the risk of late life dementia. Head injury may increase risk. Depression. So depression has been quite controversial because often the studies have looked at depression in late life in studies of older adults where it could be a prodrome of cognitive decline. But in newer studies, they've actually shown depression in midlife. So when there's been a long enough time period between the onset of a major depression and the assessment of clinical diagnosis of dementia to the point where people think it is an independent predictor now, as well as being a prodrome. So there's sort of a bi-directional relationship between cognitive decline and depressive symptoms. Anxiety, it's very unclear. We've seen very mixed findings on whether anxiety is a risk factor for dementia, and similarly stress is also very unclear whether that increases the risk or not, and there's a lot of issues in how they're measured and whether they're overlapping and what happens when you adjust for depression. That tends to remove the effect, etc. Stroke increases the risk of vascular dementia clearly, and there's obviously there's a type of dementia called post-stroke dementia. Hypertension has been a lot debated. I don't know if any of you have heard of the clinical trials that were published, the Sprint Mind trial that came out this year. Anyone heard about that in the JAMA? So there's evidence now that not only does hypertension, particularly midlife hypertension, increase the risk of late life dementia, but blood pressure lowering reduces the risk of dementia and cognitive decline. High midlife cholesterol has been shown to increase the risk of late life Alzheimer's disease, but not vascular dementia, but late life high cholesterol doesn't. So one of the differences in this field compared to heart disease, everyone says, oh, isn't it just the same as heart disease, and aren't the risk factors the same? Well, actually, there's a big difference between the midlife and late life risk factors in dementia and heart disease. And a number of these risk factors actually don't have any effect in older adults. They're mostly when we measure them in midlife and we follow people through. So another one that's not on there is BMI. So BMI, high BMI in midlife increases the risk of Alzheimer's disease, vascular dementia and any dementia, and that's a dose-response relationship. So obese BMI has a bigger effect than overweight BMI, and underweight BMI is also a risk. But that's only in middle age. So older adults who have a higher weight, so from 65 and older, don't have any increased risk. So in the environmental factors, we've got air pollution, which has now emerged as quite a significant risk factor, passive smoking, and there's not much on things like neighbourhood. There's some evidence on SES, and pesticide exposure is also now, it used to be just known that pesticide exposure increased the risk of Parkinson's, and that's now expanded to include Alzheimer's disease. So these are another list of risk factors. Low blood pressure, midlife, atrial fibrillation, they've gone through the obesity, underweight, and then what about all the medications? So people who take antihypertensives do have a reduced risk. People who take anti-inflammatories, there doesn't seem to be an association. Hormone replacement therapy does not reduce the risk, despite what you might hear on the media. There's no evidence at the moment in any of the systematic reviews that it increases the risk, and in fact, that it may increase the risk of some outcomes. High blood glucose increases the risk of late life cognitive decline and dementia, and that is even in people without diabetes. And high homocysteine, which is often a result of having low B12, increases the risk of renal dysfunction. And something like statins, we see in observational studies that they are associated with a reduced risk of late life dementia, but the RCTs haven't found any benefit, so we don't know what to make of that. And that's often what we keep finding is there's a difference between the observational data and the RCT data. It's a problem at the moment in the field. So I just want to go through some of the risk factors now in more depth and show you how some of these conclusions are made. So when we make the conclusions, and this is how we write the guidelines, we use meta-analyses and pooled estimates. We'd never just take the results of a single study, because you know how you get variation in studies. You know, 1 minute you hear coffee is protective, the next minute it's wine, etc. The next minute it's something different. So we have to have evidence that's of high quality from systematic reviews and randomised controlled trials. And so this is cognitively engaged lifestyle, and this one was quite problematic because it's very popular, and we like to tell people that, you know, use it or lose it, and it's important to stay cognitively active, and it certainly feels that way subjectively, but the literature actually people have had to pull studies with quite different exposure measures. So this systematic review did find that it was cognitive engagement was associated with a reduced risk of dementia, and they looked at things like crosswords, reading, games, and using a computer. And they defined it as unstructured leisure activities which elicit a mental response from the participant. it's not a very well-defined area. The Mediterranean diet, so I give a lot of talks, I do get a lot of questions around diet. So there's the 3 diets that are looked at in the area of dementia. There's the Mediterranean, the DASH and the MIND diet. So the Mediterranean diet has come out in the meta-analyses as reducing the risk of mild cognitive impairment or Alzheimer's disease over 2 to 8 years. There's an issue with this research in that a lot of it's conducted in the US, so you really need to look at the comparator diet. So if the comparator diet is really bad, then probably any healthy diet is probably going to do better. So it's, and often they only compare a bad diet and a good diet. So you don't know if it's actually just good versus bad diet, or it's the Mediterranean diet per se that's beneficial. There's theoretical reasons why you think the Mediterranean diet was good for you, because it's good for the heart, but it wasn't designed to optimise brain health. There's a DASH diet, which is dietary approaches to stop hypertension. That's also been shown to be protective, but there's some similar issues in the research that we have with the Medi. So the one that the most evidence is for now, I'll talk about the Western diet, and I'll talk the best diet at the moment is the MIND diet. So the Western diet, this is some research that was done on the Path Through Life study out of ANU. So in this study, we compared participants with a poor diet, high in meat, potatoes, soft drinks, low in fruits, vegetables, grains and fish, and compared that group to a group who ate a healthy diet and looked at their hippocampal volumes, and then looked at the hippocampal volumes in 4 years and found that the people that ate the unhealthy diet, which was called a Western diet, not only had smaller hippocampal volumes at the first occasion of measurement, but they also had more hippocampal atrophy. And that really mirrors what's shown in the animal studies, that a poor diet is associated with brain atrophy. So the diet that's most popular now in the field is the MIND diet, the Mediterranean DASH Intervention for Neurodegenerative Delay. That was developed by Martha Morris from New York. And she has sifted through all the literature to identify the neuroprotective nutrients and design this diet on the basis of animal and human literature. And that's the actual diet there on the left. It is a work in progress. She says she's improving it all the time. And it's been shown to reduce the risk of Alzheimer's pathology on autopsy. So when in the studies where they've followed people long term and actually looked at brains, it's been shown to reduce the risk of clinical Alzheimer's in long-term studies where they have clinical diagnoses. And the diet also, we have published the only study on the MIND diet outside of the United States on our Australian cohort, and we also found that the MIND diet was neuroprotective and it reduced the risk of cognitive impairment and dementia in Australians, and that was when we compared it to the MIND, to the Medi diet, and 2 versions of the Medi. There's the Greek Medi and the normal Medi. So this is a high quality study because we actually had another dietary pattern to compare it to. The features of the MIND diet are that it includes eating green leafy vegetables every day, so salads every day. It's not just eating vegetables, it specifies the type of vegetables, and it's thought that that's due to choline and other nutrients in the vegetables, and also eating berries 2 or more times a week, and it includes red wine.
Right.
So yeah, the alcohol story is really complicated. I'm going to get to that soon, but everyone likes that one. So I just thought so it's really interesting on the alcohol. So the relative risks of dementia and cognitive decline for smokers, not surprisingly, smoking, we all know it's bad for you. It's also bad for the brain. It also increases your risk of dementia. I guess a lot of people don't actually know this. I did give a talk once, and one of the registrars who was in the talk actually went out and gave up smoking that day, because whilst they knew it was going to give them lung cancer and everything else, that didn't bother them, but it was hearing that it actually affected their brain that made them give up. So basically, both our meta-analysis and several other meta-analyses have all concluded that smoking increases the risk of Alzheimer's disease, vascular dementia and all-cause dementia. But I really love this study. This is conducted in Western Australia, published in 2011 in NeuRA Image, because it was a study of smoking cessation where they fortunately got cognitive measures on the groups at all occasions of measurement. And they compared 36 never smokers with 48 unsuccessful quitters and 36 successful quitters. The quitters showed no cognitive decline. So the quitters actually ended up similar to the never smokers, whereas the unsuccessful quitters did show cognitive decline over a 2-year follow-up. and there was also brain changes in atrophy, so that the successful quitters had less atrophy as well. So we started to see some reversal. I don't think they found full reversal, but this is adults in their 70s. So I love this because it is a good study for arguing that there's cognitive benefits of giving up smoking even in the 70s. We also find benefits of taking up physical activity in the 70s as well. So alcohol, I probably have given an entire talk on alcohol because it's quite complicated and very controversial in this area, and very polarised. So the systematic reviews find that light to moderate drinking is associated with a 20 to 30% reduced risk of Alzheimer's disease and dementia and less cognitive decline. So, and we've seen this over and over again in all of the studies that we've conducted, both the systematic reviews and the cohort studies. And I read another recent study that's come out, I think it was in JAMA, that also found this, and that the never drinkers and the very heavy drinkers are both doing worse. So the problem with this finding is that people don't accept that alcohol is protective. So it's because it's all observational and we can't really have an ethical randomised controlled trial. And it's often argued that the abstainers, who's usually the reference group in these sorts of analyses, is not people abstain because they have a medical problem or they're on a medication, so that they're not a true comparison group. And we constantly find that the abstainers, particularly lifetime abstainers, have poorer cognitive test scores and also an increased risk of cognitive decline in dementia. So, and there is neuroimaging data. So I've even been on online debates about this. There's people with neuroimaging data showing that there's actually a linear relationship between alcohol consumption and sort of white matter changes and atrophy in the brain. We also know that very heavy drinking can lead to a type of alcohol dementia. And of course, when we give a message, we always have to give the NHMRC guidelines, and we know that alcohol consumption increases the risk of some other health outcomes, such as some types of cancers. But overall, we still come back to the fact that actually in our observational studies, we do find that light to moderate drinking is associated with a reduced risk of dementia. So we still don't really know how to interpret this, and so what we say is we always just refer to national guidelines for drinking, and we wouldn't recommend that someone start drinking if they don't. We wouldn't say that the evidence is strong enough to recommend it as neuroprotective, even though, yeah, so it's an interesting one. It's complicated. Physical activity. There's probably the most research on physical activity. There's lots of trials, there's lots of animal research, and I really like this systematic review because it puts it clearly in that they analysed the observational data in terms of studies that had looked at people who adhered to national guidelines versus didn't adhere. Because one of the problems with systematic reviews is you often get things like low versus high, and you might get an effect, but you can't actually translate that into anything. So this study just looked at it sticks to guidelines, doesn't stick to guidelines, and they do find a reduced risk of dementia amongst people who stick to national guidelines or meet national guidelines for physical activity. So that's good. However, it's not without its controversy. So even though we've got strong consensus around physical activity, there have been a series of articles in the BMJ over the last year or so which have kind of gone against the grain on physical activity. So this is a bit like a teaching point for an EPI course on reverse causation, this slide. So this actually goes against the bulk of the evidence. I just thought I should present it because it is from the Whitehall study, which is a very significant long-term study in the UK of civil servants. And if you look here at this data, so they've followed people up for 28 years. This is before diagnosis. So this is just the people in their sample who developed these are the people who developed dementia, and these are the people who didn't. So if you just did started your study here, which is fairly typical for an ageing study, and you had none of this prior data, you would say that people who developed dementia had lower levels of physical activity than the people who didn't develop dementia. But when you go back further, say to here, they actually had the same level of physical activity. So this kind of throws a bit of spanner in the works it actually goes against a lot of the other observational literature. the measure that the Whitehall uses for physical activity isn't great. It's a questionnaire measure that's not highly sensitive. It probably wouldn't be as good as what's used these days for physical activity. And there's also all sorts of other issues like reporting bias once people have cognitive impairment, etc. So I just thought I'd show that just to complicate things. And I know that sort of leads into the next section, which is the challenges that we have as researchers in the field for interpretation. So we're trying to interpret all this observational data, understanding that the actual pathology for Alzheimer's disease starts 30 years before the clinical diagnosis. So if we had a life course imaging study, we would start to see amyloid in the 50s and people being diagnosed in the 80s. So that's why it's so difficult to just sort of take a slice or even a cohort and start at 70 and go, oh, look, this is a risk factor, when we're not linking it back to the biomarkers. So there's a real need, and there's emerging studies now where they have the amyloid biomarkers from midlife, where we're trying to link them to risk factors and modifiers. But there's a lack of consistency of results for some risk factors. Most of the data is still for Alzheimer's disease, and in fact, in late life, most dementia is mixed pathology. So it's not just Alzheimer's, the majority is not Alzheimer's, so that's a problem. The average age of exposure varies a lot, and that seems to be critical, particularly we know it's critical for BMI and for cholesterol, but it may be critical for something like HRT or antihypertensives, some of the drugs. So there's insufficient data on that. There's not very much data by any type of population subgroup, whether it's Indigenous, whether it's by gender, by disease subgroup, anything. This is mostly quite aggregated data, so there's a problem with that. This is the list of risk factors from our umbrella review of the literature. This is the list of risk factors for which there wasn't systematic review data from middle age. So there's a lot there. So like bilingualism is now thought to be neuroprotective, but all of that's from studies of older adults. And you can see from that physical activity slide I showed you that really you need to have data going back to middle age. Anxiety, we don't have any data from, all of the data is from old age, cancer, depression, hormones, inflammatory markers, metabolic syndrome, etc., etc. There's individual studies, but not at the level of systematic review for these. So, or not many studies, there might be one or two, but not at the level that we'd like to see. This short-term follow-up versus the long-term duration of pathology, and tau actually accumulates prior to amyloid beta. So tau is the other type of neuropathology that underpins Alzheimer's disease. We have two types of neuropathology, and that starts earlier, so 30, 40 years trajectory. The clinical criteria for diagnoses have changed over time, so like DSM's changed. I'm sure that happens here with your research, that's a problem. We've got different quality of measures over time, like physical activity, and even thresholds, like how do you define hypertension or cholesterol, that's changed. And different countries have different thresholds, and we lack studies that can link to a biomarker. That's a big problem. We also looked this year at the global source of the evidence to see where we were getting our information from. And most of it, the largest amount is from Europe, and the second largest amount is from North America. There's actually very little data from Australia and Oceania on risk factors for dementia, and we're missing data altogether in these areas in our region. And there's virtually no data from Latin America or the Caribbean, with the exception of diabetes. This is high quality long-term cohort study. So something like BMI in particular, it's mostly from North America and Europe, so we don't know how BMI in Asia, what the cutoffs are and if it's a risk factor, etc. And same with diet, we don't know much about how the different diets globally impact on dementia risk. So this is quite a limitation of the research. We also lack a lot of, we know quite a lot now about the genetics of Alzheimer's disease, but that has, we lack data on interactions with the main genetic risk factor, and cohort effects are rarely considered, or those, and history effects. There's been really different experiences for different cohorts in terms of nutrition and war experiences, trauma experiences. education, medical treatment, mental health, etc. So that needs to be taken into account. So we've just released the GP guidelines for dementia risk reduction through the NHMRC the Cognitive Decline Partnership Centre, and that was based on the observational evidence. We've also developed risk tools, and like this is one, there's many other people, or groups that have developed risk tools, and we've validated these on external cohorts. So these are all elements of sort of trying to work towards prevention, and we're still doing a lot of work on developing risk scores that are common with other chronic diseases. We've modelled the benefit of risk reduction in Australia, but the main area of prevention at the moment globally is something called the Worldwide Fingers. It's a big consortium of multi-domain risk reduction trials where people are trying to develop interventions across, cardiovascular risk factors, lifestyle, diet, physical activity, cognitive engagement. This was the first one that's kind of started the whole trend. It's called the Finger Trial. It's a Finnish study led by Mia Kivipelto. And 2 years, their results showed that people on their multi-domain intervention had more improvement. So you've got to read this slide the right way. Most people forget this is actually looking at practice effects and their cognitive measures, but they had more improvement in cognition than the control group, and they've had a lot of other publications showing other benefits in terms of other physical health outcomes and quality of life. There's now a number of trials. There's some in Australia, there's some in Singapore, China, India. So this has become a global movement, these multi-domain trials. Then there's also a lot of research on very fine-grained individual risk factors as well. So these trials tend to have, thousands of people, multi-site. They're very complicated and they're not clean. They're very pragmatic sort of trials. This is the protocol for that trial, which has become the sort of like, this trial, in my field, this is incredibly famous, this trial and the protocol. So it's very complicated, involved about 240 sessions face-to-face over 2 years. It's not something that would be implementable in Australia. It's too expensive, and I don't think that Australians would comply. So we've been looking at, there's a lot of things like looking at online interventions, etc., to try to get more realistic interventions. So just to summarise, this cognitive impairment and dementia do already affect millions worldwide. There's multiple factors that impact on cognition, so we need very wide-scale population health approaches. We think midlife is the time to intervene, and we need culturally determined interventions. And I just want to, these are just very quickly run through these. I've given you a huge amount of information, so what we've tried to do is develop, we work with different theoretical frameworks, and these are just examples. So we take a life course approach, we look at, which is basically what I was explaining in the beginning about having a trajectory and looking at how things modify that trajectory. We also take a socio-ecological model when we're trying to think about how to influence policy in all the sectors that you would need to influence. Things like air pollution is going to have is going to require a policy response, and environment, addressing things like fossil fuels, etc. Whereas, there's behavioural interventions for lifestyle risk factors, etc. So we recognise that it's very complex. There's multiple domains that you need to address. And we also, this is another model that I work with, the Cognitive Health Environment Life Course model, which also looks at the different levels of intervention from policy through to defining that really a lot of the lifestyle risk factors impact on some common diseases, which are depression, diabetes and cardiovascular disease. So they seem to be the common chronic, the NCDs that are leading to dementia. So we're trying to team up with the other NCDs, and that's all. So I guess that another summary slide, that we need continuous, rigorous, informed evaluation of the evidence and trials, animal studies, but also policy work to try to make a difference.